students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as semiconductors. Right? Now, let's see what do we mean by an analog signal. What is an analog signal? A signal that continuously changes or a continuously varying signal is called as an analog signal. Right? Continuously varying signal is called as analog signal. Right? In that case, what is a digital signal? What do we understand by a digital signal? A signal that has only two discrete values is called as a digital signal. A signal that has only two discrete values is called as digital signal. So you have analog signal and you have digital signal, right? So now electronic circuits are designed only for two states, that is either they are on or they are off, and hence they are called as digital circuit. That is, electronic circuits can handle electronic circuits that handle digital signal are called as digital circuits. Fine. Next, what do you mean by logic gates? What are logic gates? Logic gates are designed for two-state operation, either high or they are low, right? They are nothing but they are digital signals, digital circuits, sorry, right? So, what are logic gates? A logic gate is a digital circuit. A logic gate is a digital circuit designed for two-state operation. Designed for two-state operation. Designed for two-state operation. The output is either low or high. The output is either low or high. So that's two states of output. Fine, do we get this thing clear? So a digital circuit with one or more input signal but only one output signal is called as a logic gate. Another way of defining this would be a digital circuit. A digital circuit with one or more input signal. One or more input signal. One or more input signal but only one output signal. But only one output signal is called as logic gate. Fine, do we get this in clear? Now, so we understand what is logic gate. A logical statement that a logic gate follows is called as a Boolean expression. So what is a Boolean expression? Boolean expression. A logical statement. That a logic gate follows. Is called as Boolean expression. Fine. So do you understand what is a Boolean expression? Now let's see what are the different types of gates that we have. First is the OR gate. Right? What is an OR gate? An OR gate has two or more input but only one output, such that the output is high if one of the inputs is high. Right? How do I define an OR gate? An OR gate is a logic gate that has an OR gate is a logic gate that has two or more inputs, but only one output, such that the output is high, if one or more inputs is high. If one or more inputs is high. That's what is a OR gate, right? Now, it is called as a OR gate because if its output is high if one or more inputs is high. Now how do I draw an OR gate? It has two inputs. Symbolically, this is how you represent an OR gate. This is your symbol for OR gate, where you have two inputs A, B, and you have output Y, which will be A plus B. Fine. In terms of its electrical circuit, what is a OR gate? An OR gate is nothing but a parallel circuit. So the circuit diagram for this is, it is a parallel circuit having two switches A and B connected in a circuit. Supply, resistance, and here you would have a filament, right? So here this is AB, this is my output Y, right? What is the input and the output for an OR gate? Input, there are two inputs for an OR gate, A and B. Output, there is one output for the OR gate Y, which is equal to A plus B. Now the inputs can be low or high, right? If both the inputs are low, the output is low, otherwise the output is high, right? So this is going to be my truth table. So this is your symbol, this is your electrical circuit, and this is your truth table. Right, that's how an OR gate works. Fine, do we get this thing here? Okay, next let's see the uses of OR gates. Where do I use OR gates? Where would I use OR gate? It is used in security systems. Used in security systems. Fine, do you get this thing here? So that's your use of OR gate. Next, the next thing that you have is an AND gate. Right? AND gate. What is an AND gate? An AND gate is a logic gate. An AND gate is a logic gate that has two or more inputs. But only one output. but only one output, such that the output is high, such that the output is high, the output is high if all the inputs are high, if all inputs are high. Fine, do we get this in here? Now let's see the symbol for an AND gate. These are your two inputs, A, B. This is your single output Y, which is A and B. Electrical circuit for this. Electrical circuit is, it's a series circuit. Resistance, and you have your filament here, which is your output. Right, this is A, this is B, this is your filament output Y. Right, that's your electrical circuit for an AND gate. The input output truth table, input, it has two inputs A and B. Output, it has one output Y, so that's 0 0 1 1 0 1 0 1 0 0 0 1. So the output will be high if both the inputs are high. Fine, do we get this thing here? So that's your AND gate, right? Again, where do we use AND gates? AND gates are used in burglar alarms. They are also used in digital circuit, where you require a number of pulses to be passed and to be blocked. So they are also used as security system. They are used in security systems. Fine, do we get this thing here? Next, let us see NOT gate. NOT gate. A NOT gate has one input and one output, where the output is opposite to that of the input. A NOT gate has one input and one output, such that the output is opposite of the input, is opposite of input. Fine, do we get this thing here? A NOT gate is also called as an inverter because it inverts the input. A NOT gate is also called as an inverter, as it inverts the input. Fine, do we get this in here? Let's see the symbol for this. Input, output. Output is not A, right? Electrical circuit. Where you have, where your switch is connected in parallel with the output. This is your filament, and you have, right, this is my input A, this is my output Y, and that's the power supply. And the truth table, it has only one input and one output. Right, your input is 0 and 1, output is going to be 1 and 0. Fine. So that's my A, which is going to be my input, and this is Y, which is going to be the output. Right? Okay. Now, using these three basic gates, I could make more gates from them. I could make a NOR gate. Now what is a NOR gate? Next, the next gate that you have is a NOR gate, right? Now, a NOR gate, it is a combination of an OR gate and a NOR gate, right? NOR gate, it is a combination of NOT gate and OR gate, right? In this, the output of the OR gate is connected to the input of the NOT gate. In this, the output of the OR gate is connected to the input of NOT gate, right? Thus, the input of OR gate gets inverted to form the NOR gate. Thus, the input of OR gate gets inverted to form NOR gate. Right? So, what is a NOR gate? NOR gate is where the output of OR gate, this is A, this is B, this is my output Y, that's my A plus B, is connected to a NOT gate. Right? So here I get Y is A plus B NOR. That's your NOR gate. Right? Output of OR gate is connected to the NOT gate to invert it. Right? Symbol. Your symbol for NOR gate is similar to that of OR gate, except that you have this circle over here. So this is A, B and Y is equal to A NOR B. Right? Now, what is a NOR gate? A NOR gate is electrical circuit for this. Electrical circuit is made up of your NOR gate. This is A, this is B, this is Y. Okay. That's your electrical circuit for NOR gate. Fine. Next, input output truth table. Input output. Input is A and B, output is Y. Input is 0 0 1 1 0 1 0 1, right? Your output will be inverted OR gate, so 1 0 0 0, right? So that means if both the inputs are low, then the output will be high, otherwise the output will be low. Fine, do we get this thing clear? So how do I define a NOR gate? Thus, the output of the NOR gate is high only when all the inputs are simultaneously low, right? So that's called as a NOR gate. Definition wise, if they ask you definition of NOR gate, definition, the output of the NOR gate is high. The output of NOR gate is high only when all the inputs are simultaneously low. Only when all the inputs are simultaneously low. That's your NOR gate, right? The next gate that you have is NAND gate, right? What is a NAND gate? It is nothing but a combination of AND gate and NOT gate. It is a combination of AND gate and NOT gate. It is a combination of AND gate and NOT gate. The output of the AND gate is connected to the input of the NOT gate. The output of AND gate is connected to the input of NOT gate, right? Thus, the input of the AND gate gets inverted to form the NAND gate. Thus, the input of AND gate gets inverted to form the NAND gate. Fine. Now, let's see this. How is the NAND gate made? The input of the AND gate gets inverted to form the NAND gate. The output of the AND gate is given to the input of the NOT gate. So the input of the NOT gate is inverting this, right? Now, how does this look like? You have AND gate. Connect the output of the AND gate to NOT gate. You will get your NAND gate. This is A, B. This is A and B. This is Y, which is A and B NOT. Right? Symbol for this is going to be A, B, Y is A NAND B. Right? Electrical circuit. Electrical circuit is, this is your filament, which is your output. You have two switches that are connected in parallel, and you have power supply over here. This is A, this is B, this is Y, right? Next, truth table. Input, output. A, B, Y is A NAND B. 0, 0, 1, 1, 0, 1, 0, 1. Right? So your output will be 1 if any of the inputs is high or both the inputs are low, and if both are high, only then your output will be low, right? So how do I define this? I can say that the output of the NAND gate is low. The output of NAND gate is low only when all inputs are simultaneously high. Right? That's my NAND gate. So those were all the gates that you need to know, right? Okay, we'll stop this here for the day. Thank you very much.